All right, it's 2 p.m., so we're going to go ahead and get started. Welcome to Advanced Kentucky's online content review session for AP Computer Science Principles. My name is Aaron Timmons. I'm the Mathematics Content Director. I'm joined today by Dr. Sherry McGuffin. She is our STEM coordinator, and our presenter, Miss Joanna Stevens from Garrett County High School. She will be leading us through the CREATE task, one of the performance tasks for the AP exam. Just before we get started, going through a couple housekeeping items here. All of our contact information is right here. So we have Twitter, Facebook, emails. Feel free to give us a follow, reach out to us if you have questions after today's sessions about anything at all. Your microphones are going to remain off for the duration of the session. Please make sure you are utilizing the chat feature. If you have any questions, Dr. McGuffin and myself will be monitoring that. So please make sure you find that chat button at the bottom of the Zoom meeting. You also need to make sure your audio is enabled so that you can hear all of us speaking. So if you're not hearing us, that could be the reason why. So give that a check. Your videos will remain off for the entire meeting. So please make sure you're aware of that. Also, hopefully you found our information through the kyap2020.com website, but if not, I encourage you to check that out. It's got all of the future events for all math, science, English, computer science review sessions, as well as general resources in addition to that, so please check that out. It's a very useful resource. And before we begin, we're going to pause the recording here for about 3 minutes. I'd like you all to sign in. If you can just minimize the Zoom browser, open up your own, go to this bit.ly link here, sign in. It's a quick 4-question Google form. We just want to kind of keep track of who all is watching so that if we have questions or if you have questions, you can reach out to us. So I'm going to pause the recording. It'll take about 3 minutes. For those of you that are joining now, just go ahead and click that link and sign in, please. All right, so hopefully you've had enough time to go to that link and sign in for us. A couple other notes here. We are going to be utilizing the chats feature exclusively, as I said earlier. You are able to chat directly with any of the co-hosts that you see on the screen. If you send out a chat to anyone else, it'll be a general public viewing. I know that can kind of intimidate some people, so please make sure you're very open with it. We are very inviting, encouraging of all comments. And I also realize there's a lot of teachers as well as students here. So if you are a teacher and you have specific questions, feel free to send those out. Joanna and Sherry and I will be happy to address those as well. And then students, you can ask any questions you all would like. So without further ado, I'm going to stop sharing my screen, turn it over to Joanna.
Ask mommy. Shut the gate, please.
Turn it over to Joanna, who can share her screen and she can introduce herself, let her know or let us know a little bit about you, Joanna, and then take it away.
Okay. Thank you, Aaron. So I'm Joanna Stevens. I am a math teacher at Garrett County High School. That's in Lancaster, Kentucky. So we're about 30 minutes south of Lexington. So you just go past Fayette Mall and keep going, and you end up in Lancaster. I'm a math teacher there. I teach Algebra 1, Algebra 2, and AP Calculus. This is my first year there. So I used to teach AP Computer Science Principles. I've taught it for 2 years. My new school didn't offer it, but I'm happy that it is on the schedule for next year. So thank you for joining us today. So we're going to focus on the CREATE task. And then I'm going to use Desmos as our platform to kind of communicate today. So everything we do will be available in this Desmos activity. So I'm actually going to have you, let's see if I can share my screen now. Okay. If you could go to student.desmos.com and enter in this code. It is not case sensitive and you don't have to have that space there either. But once you're in there, go ahead and do the first 3 screens to just kind of give me an idea of where we're coming from. So this will just give us an idea of where we are on the create task and what questions you have before we get started. Okay, so we'll do another minute to give everybody a chance to respond. So I am using Desmos as the platform. And just to give you an idea, so when you signed in either with your Google account or you typed in your name. But I have used the anonymize feature. So all of you have an anonymous name. So I'll be featuring some responses, but it's anonymous. So this makes the class safe if we're in a traditional classroom, but even the digital classroom, no one feels singled out or picked on if I'm, highlighting a response. And then another cool thing as a math teacher, these are all famous mathematicians, which some of them are also computer scientists, you'll see. But just that's a nice feature about Desmos. I also have the ability, like on screen 1, where it's just, how are you feeling today? Just to check in. I can see our individual responses. And then I can also see where we're putting our dots. So I can see, like, for the most part, we're feeling pretty good from a blah state to we have lots of happy robots here. And I know personally for me, it seems that my days go with the weather right now. Since I can't go anywhere on the sunny days, I'm a little happier because I can go outside at least. On the second screen, I just kind of wanted to see where we were on the create task. So I know different schools got out at different times and different classes were at different places. So we have everywhere from, it looks like we have somebody who is done. They have submitted it to the digital portfolio. To everywhere, one, we haven't started. You still have plenty of time. There's no reason to freak out. You have lots of time to finish it. And then it looks like we have some people in the middle that we've made a little bit of progress on your way to finishing it. So it looks like we're all over the place, which was to be expected. And then on screen 3, looking at some of the questions, lots about the one parent and the 2 children algorithm. So code.org, when's it due by? Good. How complex does the code have to be? Okay, so we're going to touch on a lot of those. And if we don't hit on those, I'll come back to them at the end to make sure that everybody has their questions answered. But a lot of those, starting with like, when's it due by? So those are things that have changed recently. And to highlight some of those changes, I thought we could do a scavenger hunt. So I'm going to send everybody to screen 4. If you click on the link, it's going to take you to a flippity scavenger hunt. So these are 14 things that are really important about the create task. And if you click on the lock, each lock, it's going to have a question. And like, notice this one's been updated, that this is a new rule. So for 2020, what % of your final AP score will the create task be? So it used to be 24, but that has changed. And so if you don't know the new %, you can click on the light bulb. It's going to give you a hint, and you'll be able to find your answers at this link. So I want to give you some time to kind of play around with it, see which ones you know. If you know the right answer, I'll just do the first one with you to give you an idea of how it works. If I didn't know, if I typed in 24, my lock is still going to be locked. But if I follow the link and look it up, let's see. It's going to take me to the new College Board update site. I'm going to scroll down until I can find computer science principles. And then I'm going to look and see, this website has all of our updates, including the due date and the percentage. So we're focusing on the create task today. So that's 60%. So if I go back up to my, let's see, and type in 60, that's going to unlock my lock. So the goal is that you'll be able to unlock those. So I'm going to give you 5 to 10 minutes to work on those. I'll be checking the chat box if you get stuck on any, and we can talk about those. But I thought it would be best if we all tried to figure out the answers to those. So I'll be here to support you.
Joanna, can you give out the link to the link for the students again, please?
For the Desmos?
Yes, please.
Let's see.
Aaron, I just put it in the chat box. J4Z2T4.
All right, and then they need to go to student.desmos.com to put that in, correct?
Yes. There it is.
Joanna, I've got another question for you.
Go for it.
Can you tell, I know you have a handout that you've uploaded to our KYAP 2020 website. Will that go along with what you're doing now, or is that something
Yes.
you haven't touched on yet?
Mhm.
Okay, so they should go ahead and get that now?
Everything we do is on the handout, yes.
Okay.
Like, it has a direct link to the Desmos and
Okay.
the scavenger hunt.
And it looks like, Aaron, there's a question about the Zoom link for students. So
Yeah, I checked into that. I don't have any difficulty on this, and I've checked with others. I don't know
Okay.
what the concern or cause is.
Gotcha.
So if you have any questions on the scavenger hunt, be sure to put those in the chat box. I know some of them can be tricky. So on the questions that have 2 answers, you have to type the first one, semicolon, and then space, and then the second answer. That might help on some of those. So all of the Desmos and as well as the scavenger hunt, you can access these at any time. So like right now I'm pacing through the Desmos, but as soon as we're finished, it'll be unpaced. So you'll have access to all the slides, the scavenger hunt. So you can work on those at a later time or at a time convenient for you.
And Joanna, for teachers, they can assign this for their students that could not participate in today's study session.
Mm-hmm. And actually, from the teacher standpoint, when I made the scavenger hunt, there was no way for me to see when students completed it. But I'm pretty sure I saw on Twitter last week that Flippity has added a component due to the so many schools being out, where you can actually see when your students complete it. I usually just have my students complete it and take a screenshot, upload it to Classroom. But supposedly now they can sign in. I haven't tried that yet. So if you have any questions on the scavenger hunt, you can put those in the chat box. We'll do a couple more minutes. I know you may not be finished, but I don't want to spend too much time on it, so we can move through it.
There's a question on the chat box about the Explore task, and that has been extended as well. Explore task and the Create task have both been extended to the same date.
Mm-hmm.
So there's still time to work on both Explore and Create.
Your teacher may have set a intended due date, but College Board's due date has been extended. Okay, so I know you still might be working on those, but I'm just going to highlight some of these answers that are pretty important, some of the bigger changes. So we talked about the biggest one, that you no longer have a multiple choice exam. So that puts added pressure to the Create task and Explore. So that Create task is now worth 60%. And then in the chat box, and we've talked about it, the deadline is now May 26th. So that has been extended. I know it's 11:59 Eastern time, so you want to pay attention to your time zone. On the third block, collaboration is allowed and even encouraged in the planning, designing, or testing, debugging part of the development process. So even though that we're not in the classroom, you can still collaborate as you're writing your code. You just want to be careful on which parts you collaborate on. So it is allowed for planning, designing, and testing part of your development process. For 4, you're required to independently develop an algorithm that integrates 2 or more algorithms that is fundamental for your program to achieve its intended purpose. And so this is one that a lot of you had questions about in the Desmos, that you have an algorithm, and we call that one usually a parent algorithm that integrates 2 smaller ones or 2 children with it. So that's something we want to pay a lot of attention to. On 5, you're required to develop an abstraction that manages the complexity of your program. So you want to make sure that abstraction actually, helps your program, that it's not just there to say, a program is there, that it actually manages complexity. Let's see, ready for block 6. You are independently required to create a video that displays the running of your program and demonstrates its functionality. So we're going to talk more about the video and how you can make that at home. You're independently required to write responses to all of the written responses, or the prompts, I think is the word it's looking for right here, in the performance task. So the prompts, we're going to spend some time about those because sometimes we get so caught up in the code and the video, but most of your score for the Create task comes from your responses to the prompt. you're required to submit your entire program code as a PDF. I know my students got so caught up on putting a rectangle and an oval around their abstraction and algorithms, and sometimes they forgot the entire code also has to be attached in the digital portfolio. So if we keep going, the video that you make must not exceed 1 minute, and it must not exceed 30 megabytes in size. So the video doesn't have to be extravagant. It doesn't have to show the whole program. It just needs to show one function of your program running. That was the same one. 10, the written responses need to be a PDF file, and those cannot exceed 750 words. That doesn't, when we're talking about your program code, that is exclusive of that. And then once we talk about, let's see, your abstraction, you're going to put a rectangle around your abstraction to highlight that for your reader. So I tell my students that we want to make our readers as happy as possible. You want to make it easy for them to find things. So you put a rectangle on there. And then we're going to put an oval around the algorithm that we have. And we want to make sure that our algorithm has math and/or logic concepts. When you're making your code, it is okay and it is even encouraged to put comments as you go to explain your code, but especially you must do it if you are using any code that has been written by someone else. So I know sometimes we use, like if you're using code.org, if you're using code that is from a previous lesson, a lesson where you have feedback or a lesson that code.org guided you to, you need to put a comment to credit code.org or whoever for that code. So make sure that you're not taking ownership for something that you didn't write. And then the last one, for the create task, you will submit 3 files to the digital portfolio. And so this is something, the digital portfolio, I would go ahead and if you could not access that, I would make that your #1 priority right now, is to make sure that you can log in to your digital portfolio. Because you may have to call College Board to get your password. So that's not something your teacher will have access to. You'll actually have to call College Board if you cannot access the digital portfolio. So I know you may not have finished all the logs. They're still there. You can go back and look at them. The hints will stay there, and you can do those anytime. That link will stay up. So now I want to shift gears to the written responses. And actually just go back to the Desmos screen. So on the Desmos screen, we just did the flippity hunt. But now I want to talk about how important the written responses are. So your video is just 1 row of your 8 points, but all of your other points come from these written responses. So we want to make sure that when you write them, that you make your grader happy. You don't want them to have to look around to find your answers. You don't want it to be a scavenger hunt for them. So I want you to look ahead. I'm going to go ahead and give you 5 screens. Each screen is going to give you one of the written response prompts. So like this one is 2A, and it asks you to provide a written response or audio narration in your video that identifies those following things. So I don't actually want you to write the response, but just kind of write your sentence starters. How would you start writing these things? Just to make sure that when we write our written responses, we don't forget anything. So I'm going to give you, I guess maybe we'll try to do this one in 4 or 5 minutes, just to write down some different things that you can include in these responses.
And Joanna, can you stop sharing the Desmos screen and then share the response screen? There we go. Thanks.
There you go. Sorry. I forgot to do that. Okay, so if we look at that first response, and we can see some of the different answers that we came up with, these all look like they would be great. If we check in with Camille Jordan, for the following code, Python was used as the language. Essentially, the purpose is to entertain or to inform, etc. As can be seen in the video, a certain code can be seen for the purpose of blank. So that last one is what my students often forgot. You know, they did their video and they were so proud of it, but they forgot to reference it to tell what the video was doing. And that's different than the second bullet, because the last bullet doesn't necessarily show the purpose of the program. It just might show one feature. On the next response, to B, so it looks like maybe we're still typing on this one. So this is a good one. I like what Carl's doing. First, I did this, then I did this, followed by this. Just kind of write it in the order that you worked on things. For this one, I encourage my students to make notes that, you know, to like at the end of each day when you work on it, what did you do? And write it down in order. So then at the end, this one's not hard to write. But the biggest thing on this one, so you want to do your process of how you worked on your program, but also difficulties or opportunities. And you have to include at least 2 of these. So it can be 2 difficulties, it can be 2 opportunities, or 1 of each. So a lot of times my students didn't want to say something they struggled with, but I know I've never written any code where I didn't struggle at some point, you know. So to talk about how did you go back and debug, and how did you, and sometimes it's just, I kept trying until I got it right. But opportunities, you know, maybe you saw an opportunity to make it better, to make your game more engaging or competitive or just prettier. You saw an opportunity to put in a background, to make it, you know, more aesthetic. But make sure that you focus on the process. So that's where you're going to use first, then, but then make sure you highlight at least 2 difficulties and or opportunities while you're working on that. And then I'm glad Carl went ahead and put that on there. Don't just identify the difficulty, but talk about how did you resolve the issue, or how did you resolve the opportunity? What did you do to fix it? So on the next one, you're going to talk about your algorithm, and you're going to talk about how the algorithm works, how they work independently, as well as in the combination of others, to form your big algorithm. So how do your baby algorithms work to do their job compared to the big algorithm, to make sure everything works together. And so this will also be where you will have some math in it. And we just want to be really careful when we make our explanations for these, on how we're explaining how things work. So like one algorithm might be that I made this algorithm to calculate my pay based on how many hours I worked, my hourly pay. Another algorithm might calculate my overtime pay because I get time and a half. And then my big algorithm takes both of those together and adds them together. But the 2 baby ones can both do their jobs without each other, that they function independently. And then on number 9, we're going to talk about our abstraction. And I encourage my students to use that code, use those words. It manages the complexity. And how does it do it? Why do you need the function that you've written, or whatever abstraction you're using? What would be more complicated if you didn't use it? You know, by writing a function, I only have to call the function instead of writing the code the 5 different times. But explain how it manages complexity. So please pay attention to our written responses. We don't want to forget those. I know they're the least fun part of the whole create task, but that's where the weight of your points come from. I want to go ahead on screen 10. So I've unpaced you so you can see that. But I'm going to share just a few tips as you work on the create task that will help you. So this is just a Google slide. I'm going to pull it up, but again, just like everything else, you can access this at any time. So you probably, I hope by now, know what type of coding language you're going to use. It doesn't matter which coding language you use. The readers are trained in all of them. So don't pick one to impress. Pick one that you're comfortable with, the one that you've worked with the most, and the one that will meet the requirements. So don't try to learn a new language for this project. That's not the purpose of that. Narrow it down. I know a lot of times we get, we have these big ideas and these big dreams for our projects, and that's good, but start simple. You want to have one working feature that you can show in your video, an algorithm with the baby algorithms, and an abstraction. These are the three things you've got to focus on first. Once you accomplish that, then you can have your big ideas, your big dreams for your project. So focus on the algorithm first. Pick one part of it. Like, that's how I tell my students to start. Focus on your algorithm. Build it from there. It doesn't have to be crazy impressive. Minimal design mode works. They're not even grading on how it looks. They're really grading, do you meet the requirements for the create task? So again, I can't reiterate this enough. Think of two algorithms that combine to form a third one. So I gave the example with pay. Another example would be I could have a baby algorithm where I record all the food I intake. So that's my calorie intake. I could have another algorithm where I have my calories that I'm burning through exercise. So basically you could have a food algorithm, an exercise algorithm, and then my big algorithm could be, subtracting what was my final calorie intake for the day. So think of something like that, and then build your program from there, because this is probably the hardest part to piece together if you're not planning around it. Be aware of time. So now that we're at home, we have lots of time, but I know I'm learning I have to have a schedule every day to keep me focused and to just make sure I'm checking things off my to-do list, because it's really easy to say, I'll do that tomorrow, since I don't have any plans tomorrow either. But focus on meeting the requirements. If your teacher is setting deadlines, try to stick to those, or don't try to, do stick to those. I know they have your best interest in mind when they're setting those. Make a list of things that you want to add to it, and then do those once everything else is done. So tackle your list first, and then I tell my students they can make it sparkle. But make sure you have everything else finished before we start adding in those extra pieces. So help, so you're not allowed to get help from your teacher or another adult on the whole process. You are allowed to get help from a peer on the development process. So you can brainstorm with them. You may not talk about the written responses with them. So this only applies when we say development process for your code. You can troubleshoot if you can share what type of, I can't get my code to do this. But you've just got to be careful on who you talk to and what you ask. So this goes back to the opportunities or challenges. So this is like, I kind of have my kids journal as they go. Write down what you do every day. So that way you know what's going on. And that will help you when you write your final written responses. Video formats. So you can upload in College Board accepts a variety of formats, but you do want to make sure it's one of these four. It has to be less than a minute and less than 30 megabytes in size. You want to make sure it's showing one feature of your program. So I included some websites that I've used to make videos. Screencastify is probably my favorite, but I know that we ran into some issues with my students last year on their Chromebooks with it. So sometimes Screencast-O-Matic seemed to work. Those are probably the two that were most popular. And then Gene from TechSmith. And then something that's, I know, distracting. If your program doesn't have sound, I wouldn't record the sound. It's just going to be outside noise. I guess you could use Zoom to record that. I know my school doesn't allow Zoom. So that's why I don't have it on my list, but I think Zoom could be, I don't know why it wouldn't work. Whenever you save your video, and this goes for all of your files, and this is something my students often had to like go back and rename their files after the fact. You can't have your name in the file name. So I know a lot of times I might put, you know, Stevens code, Stevens video. And as the teacher, you know, that's helpful. But when we submit it to College Board, we don't want anything that identifies who you are. So make sure that for your video, you don't have your name. You cannot collaborate on the development of the video. So that's something you want to be careful of. And then don't post it. So I know we have a lot of time to post things on social media, but make sure we don't put it on Facebook or TikTok or Snapchat or Twitter. I know you're proud of what you did, but College Board asks that you not post anything from your performance task. So make sure you don't get, I would hate for you to do all the work and then get in trouble for posting something online. This is just 2 examples of the screenshots. Just making sure that we put a rectangle around it, we put an oval around it, and there's different ways that you can insert those shapes. I think these were both done in Google Docs, where we took a screenshot of the code and then we inserted a Google drawing on top of it. So you also, when we submit it to the digital portfolio, we have to have our entire code. And so I use CodePrint, which is made by code.org. And that way you can put your whole code in there. It just makes it look a little prettier. And you can save it as a PDF. And so that also means that we want to make sure we have comments or acknowledgments to any code that we got that we did not write ourselves. So you want to make sure you give credit to everyone. Make sure that your name is not in your file name or in the document. And when you are finished with all of it, you're going to upload your video, your written responses, and your entire code. So for the create task, you're going to upload 3 different things. Now the deadline is May 26th. I know based on previous years, the digital portfolio has a lot of issues on that deadline. So I encourage my students to have it uploaded before that date. Even if it's just the day before, have it all uploaded. There's been some issues of the system getting overwhelmed. Now they usually extend the date, but we can't count on that. So I would try to upload it as soon as you can, just because the system gets overwhelmed as we get closer. So before we move on, do we have any questions? So it looks like Mike has shared that digitaltrends.com has a nice short video on how to record some things. Mark shares that Zoom would be a good option. And I don't know why it wouldn't work. I think it would be a great tool to use, especially now that we're all familiar with it. Any other questions about the create task in general? To slide 4. This slide. So again, all of this is available for you to go back and reread. And I always would tell my students, like, before you submit it all, go back and reread it all. Make sure that you've met all the requirements. So Mark asked, what complexity constitutes a sub-algorithm? So I think the sub-algorithm is anything that would function by itself and accomplish something. And then the biggest issue is using 2 algorithms to do something bigger together to make the parent algorithm. I don't think it has to be super complex. You just want to make sure that one of them includes math and or logic. And so math symbols would be our, your traditional math operations. And then the logic symbols would be our greater than, less than, true, false, those types of things. And yes, it could all be in one function. I've had students before who have used their algorithm and their abstraction have overlapped. I wouldn't encourage it, but that is something that happens, and I think it's okay when it does, as long as they both meet all the requirements. So I know we don't have too much time, and I don't want to go over, but I'm going to switch back to the Desmos now. And what I've included on our last few screens, I've included one, an actual video that College Board released to just kind of show you what was something that was turned in. And I've also provided a link to their written responses and then the rubric. So I just want to give you some time to watch the video. You can hit play and play that on your screen. Or I can play it for you right here to just show what's happening in this video. And something to notice about this video is it was not a minute. So your video does not have to be a minute. It can't be over a minute, but this one was 27 seconds. As long as it shows one function of the program, that's good. It doesn't have to be too long. What I tell my students, their video, their written responses, don't make them long just to be long. They would prefer short and concise technical writing there. So what you can do is if you want to click on the written response, it's going to show you the written responses that were turned in for this one, I think. And so this is one that used Alice to create the program using Java programming language. And you can read the responses that they put. And then on the Desmos, you can read the actual rubric. What does the rubric state? And would you award them a point or not? So I'll give you some time to just look through those on your own, and we'll come back together. So I know we're getting close to the end of our time, but just to let you know, this is actually one that received all 8 points on their create task from College Board. So this is, I guess, what you would call an exemplar. So this is what we're all aiming for, because that's 60% of your AP score. I would encourage you to look at College Board's website. They have several that are not exemplar that you can look and see where the fine line is between what gets a point and what doesn't. And College Board explains why they gave a point and why they didn't. So if you have any questions, feel free to reach out to me on email or on Twitter. But thank you for joining us today. And I think I'm ready to turn it back over to you, Aaron.
Thanks, Joanna. That was a great job. All right, I'm going to share some closing screens here. So again, a very special thank you to Joanna Stevens. I think that watching this video, you can tell that she is an expert and she knows what she's talking about. So we appreciate you having you spend your time with us. Just to recap, our information for Advanced Kentucky can be found here: Twitter, Facebook, website, along with emails for myself, Dr. McGuffin, and Joanna if you have questions for her. All handouts and links to everything that Joanna did today can be found at kyap2020.com. This recording will also be uploaded to that website as well. So those of you that want to go back and view it at a later time or share with your students to view can be done. And again, if you've not had the chance to sign in because you joined late, please sign in for us. It will give us a really good way to see just who's viewing these sessions and give us a way to make sure we're maximizing our potential. So the bit.ly link is right there. Next week, we have our final CSP session, April 15th at 2 p.m. It's going to cover the Explore task with Jackie Honghorn. So she will be sharing resources, sharing tips and strategies for those of you that are still needing to complete that task as well. So unless any of you have any other comments, we will sign off. Thanks, Joanna. Thanks, Sherry. We will see you all next time. Thank you.